So in IMS DB, both the field and segment name should not have more than 8 characters, okay, and it can be alphanumeric name, alphanumeric names, okay, both. So that is one thing you wanted to notice. And then, so pretty much this is the overview of IMS DB, okay. So let us deep dive into, I mean, what is IMS and what is DBD gen and PSB gen, okay. DBD gen is nothing but DBD is nothing but database description. So you are basically describing the database, which is the IMS DB. It is similar like create table you are giving, right? It is similar to that, okay. So mostly like in the DBD you will be giving access method, okay. So there are four types of access method. One is HSAM, which is nothing but a hierarchical sequenced, sorry, some typo is there, but anyway you guys know, I guess, okay, sequential method, okay. And one more, and HISAM, which is nothing but hierarchical indexed, okay, indexed sequenced method, okay. And HDAM is HDAM, okay, it's hierarchical. So everything is a hierarchical storage here. That's why like it will say like hierarchical direct access method, okay. HDAM. And then HIDAM. So basically it will be taken care by DBA team, but we can also know these terms, right? So that's why I'm explaining it. And it is hierarchical indexed direct access method. So as the name says, here the method accessing method is sequential, like it will go one by one. And here there will be a indexed. So the storage is nothing but KSDS, or I mean vsum file, CSDS or something. So if it is a HSAM, you can create a non-indexed vsum file, that is ESDS, okay. If it is HISAM, it will be indexed and the index will be there in some other data, because KSDS will have both data as well as index files, right? So that's how this hierarchy works. So index would be nothing but the KSDS storage. And here you can access the data directly. It no need to be sequentially accessed. And HIDAM, like it will have index and you can directly access the data. You no need to go in a sequenced way. Okay. So currently I have one DBD gen. Um, okay. Let me do this first. Hmm. I mean, I use this so that you guys will have an idea. Like, let me put on a structure. Okay, I forgot to put on a structure. Anyway, we can put on a structure now. It is basically easier this way. So that's why I haven't put the structure. Okay. So here first it will say like the what is the DBD name. So let mine is like an hospital DB. So I will be using a hospital terms in here. Okay. So let us take first the DBD name. Okay, it is the database name. Basically, this is the database name. Okay, PNT DB HIS. This is the database name. Okay, so the database have n number of routes under this data. What is the segment? So basically, here I have used the access method as HISAM, which is hierarchically indexed sequential access method. Okay, so I'm giving one dataset DD1 name, okay, which is nothing but PNT DBHIS. It will be used in the storage thing. Once you are running this, what can I say? Once you are running this uh, JCL, I mean, for accessing, for using the calls in JCLs. So there we would be having, see, basically the JCL will be having like uh, so the utility to run the this IMS DB is DFS RRC00. Okay, and then in the palm character you would be giving what type of processing is that, DLI, and then what is the database name, I mean sorry, program name. So basically you will be writing on COBOL program, right? So the program name, and then the PSB name. PSB I will explain later. So PSB, let us take like PSB. Okay. And here you will ask the JCL to refer a particular VSAM file. Okay. So there the DD name would be like PTN DBHIS, and its overflow would be, its overflow DD name would be. So this is nothing but the, I mean, VSAM file name only. Okay. So sometimes the overflow is like, see, if you are giving only 100 length for the KSDS file, okay, basically, and you are my storing data more than 100 bytes. Okay, so since the root segment, see, root segment will be like 10 bytes, but the data will be, as I told, the data will be, all the segments of the data will be stored in one line, right? If it is passing more than 100 bytes, then it will store it in overflow data only. So that's why overflow is important. I mean, it's optional only. It's not like you need to give the overflow or not, but in most of the IMS DB programs, overflow would be there. Okay, so that's the use of dataset DD1. Okay, you, whenever like in the JCL, you will give DD DSN equal to that particular KSDS file name. Okay, so that's how, that's why we should mention the DD name here. Okay, so and yeah, now comes the segment. So segment name, I'm giving the segment name as patient. Okay, and the bytes is nothing but space. How much space it will take? It will take around 45 space. And parent equal to 0 means the segment is not having any parent, and this is the parent segment. Whenever the segment is 0, that means the parent is 0. That means it's the parent segment. Okay, and once the segment, this is the DBD generation. I mean, it's we have in generation is load lib basically. It, this we can call it as DBD source. Okay, once you have got the load, that is what the generation means. Okay, so this is like DBD source basically. So and then once you have the segment name should be with the macro SEGM. Okay, and it can have field names, right? So the field name is like field name equal to patient number comma sequence comma unique. That means it is having a key field, and it is a unique. As I told, a segment should have, root segment should have one unique field. Okay, then only it can go with the hierarchy processing. So that's why it is important. And as you know, it's KSDS, so the keys will be already will be in a sorted order. So that's how the storage works in KSDS. Okay, so the field name is here is patient number, and byte is 5, and it is starting from the first byte, and type can be character, C for character, Z for zone decimal, P for packed decimal, and there is a half binary, binary is there, and hexadecimal X is there. Okay, so I haven't used the binary and those things. I mean, I haven't even used zone decimal. Like in few of the things, zone decimal is not compatible. I mean, it won't support. Okay, so basically most of the things will be under character or packed decimal only. Okay, P for packed decimal basically. So once a segment name is given, you should define all its field, and the field bytes. The bytes would be the length of the length of the field and where it should start from. If you are making mistake in here during the DBD compilation, it will throw error. Okay, I will show it to you guys how it will throw error. Okay, and then it is having one more field. I mean two more fields. Okay, so basically the name and the address and the same, like how many bytes, what is the length, and then one more segment. I mean few segments are there, Let us think, go one by one. And this is the segment name. Okay, so SEGM is nothing but the macro is nothing but the segment names, and it is having illness as the segment. Okay, this is the name of the segment, and its parent is patient. Okay, since this is not a root segment, as I told, the parent for the root segment would be 0. If it is not, if some parent is there, then it will be connected with that particular parent segment. Okay, let me put a hierarchical structure here. Okay, by going one by one. Basically, first what we have given. It's okay. Okay, so first is the patient segment, right? And then its child is illness. So that's how this hierarchy goes. So it is connected like this. Okay, and illness can have fields. So here, okay, what is the see? This is the segment and name. It is having one ill date as the field. It's the field name. Okay, so that's how the difference will work. So this is the field name, and it is sequential. See, it is not mandated to queue. Okay, it is optional only. If it is sequential, this particular ill date field will be sorted in the sequential order, basically in the ascending order. And there is no there is no in IMS DB you can't order by something in descending. Okay, so basically it will be sorted in ascending order only if you are mentioning it as SEQ. SEQ they will call it a sequence field or key field. Okay, and M is nothing but it no need to be unique. It can have duplicates. So that's how M, what M means. And the byte should be overall bytes, the segment bytes. I sorry, the segment bytes is here. The field byte is, so if you add this field names, the segment should have that much bytes. Okay, if you are giving here 19, okay, and you are defining only for 18 bytes, definitely it is gonna work. The last byte it is gonna give it as spaces. Okay, uh, uh, so that's the case. You can give bytes as 20 as well, and the remaining like remaining would be having spaces. So that's how it works. And here another one segment name is there, which is nothing but treatment. Okay, and its parent is illness. Okay, so illness is the parent and treatment. Okay, wait, something is okay. Sorry, treatment, right? Yeah, treatment is the child for the illness. Okay, so and then so segment, as I told this that's the treatment. Yeah, segment name is treatment, parent is illness, and it is having not two, four fields are there totally. And this four fields, 18. I mean, I'm gonna run this particular PSB. If there is any mismatch between the length, then it is gonna throw the error. See, and sorry, one more thing. It's like if you are giving 32 here, and if you are giving 29 here, and the length mismatch is there. See, the field can't go beyond the segment field. Okay, it will throw error, but the segment can have extra spaces. Field can have, like, if you add this 8, 18, here it is 10, 18, right? So 22. So basically bytes 32. Here, if you are giving bytes as and 6, I mean, you are increasing the bytes, it is gonna throw an error saying like the mismatch is there. The segment can have only 32 bytes, and your field is more than that. That can be the case. And if you are like doing some error in the start position as well, in the compilation it will throw error. Okay, so that's how it works. And this is the segment name billing, and its parent is patient. Okay, so parent is patient billing. I think, okay. So parent is patient and the name is billing. Okay, so this is how the flow works. Hmm. So billing is there, and once billing is having only one field name, which the field name is also billing basically. Okay, so billing is having one field name and one more segment. Payment segment is there, which is the billing is the parent for that. So billing is the parent for that. Okay, so this is the payment segment. Okay, billing is the parent for that. So this is how the hierarchy, I mean connection is there. And here payment is done, household segment is that, which is the parent is patient. Okay, and it is having two fields. I mean field we won't need to like if you are making some mismatch in here and there during the DBD generation itself, it will throw error. So okay, saying like mismatch is there, it will give clear data. So that's why I'm not stressing more that on that point. So household is there. Okay, the name, and it is the parent is the. So this is how the hierarchy works. Okay, so let me tell you how the data flows here. So if you are giving some issuing some call, first it will go inside the patient segment, and then it will go inside illness segment. Okay, and from illness it will move into, I mean, you if you are doing a sequential call, it will move to treatment segment, top to bottom, and then from treatment to it will go from left to right and above one level, which is nothing but billing, and then it will go to payment. Okay, and at last it will go to household. Okay, so that's how the hierarchy works. And once after household it will give status code as GB. Okay, GB, B for Berlin. Okay, so GB, it's like end of database. So it will throw, there is no segment is there, and there is no data there basically, not segment, because if there is no segment it will throw GE. Basically it's like no data other than that. So it will throw GB. Okay, so I hope you understand how we should create the DBD source. Okay, and one more thing. So this is how the IMS DB works. Okay. Mm, okay, so let me put it here. Mm, IMS DB, what are the key things you need to do before doing a COBOL program call? So key things you need to do, like first you should create a storage for this particular DB. Create storage for IMS DB. Okay, and next you need to create a DBD gen. Okay, library. I mean not library, a load. DBD gen is nothing but a load. Same thing like COBOL load. Okay. So next you need to create the DBD gen, and then PSB gen you need to create, and then you can code a COBOL IMS DB logics. Okay, to connect and retrieve or insert data from IMSDB. Okay, so this is how it works. Okay, first I told like first we need to create the storage group, which is nothing but visa, and then the DBD gen, and then the PSB. Okay, so we have created the mostly like in the DBD, and once it is entered, you should give finish and end there. Okay, for that particular DBD gen, and then using this ASM A90 ASM ASM A90. Okay, so this is the compiler which compiles which compiles this dbdgen. Okay, it will say like error is there or not. Okay, I will show the compiler as well. I think ASM A90 only. Yeah. Okay, so and okay, so let us go inside PSBgen. See, PSB, it's the program specification block. Okay, okay, I should not touch here. Let me put the notes here. PSB is nothing but program specification block. Okay, and it will have multiple PCBs. I mean, inside PC, it is not like it should have multiple PCB. It can have one PCB or more. Okay, one PCB is also fine, and it can have more PCBs as well. Okay, okay. So this is it. Program specification block. So see, DBD is like you are giving structure for that particular database and storing it in a VSAM file. That particular structure. Okay. uh, Not, I mean, the structure won't be stored in, I mean, you are giving only data will be stored in KSDS file. You are just saying that this is my structure, similar to like create table in DB2. Okay, and PSB, in PSB what you like, you should mention all the PCB. Through this PCB only our COBOL program will connect and get the data from IMS. So that's why this PCB works. See, consider it like a, see, through linkage section we are passing data here and there, right? So consider in the IMS DB concept, this is like a linkage section which will, I mean, using this DLI commands, it will go inside the IMS and take that and put the data in the COBOL, something like that. Okay, consider it like that. So this is the PCB. Basically, the PCB, I mean, PSB will have PCB inside. Okay, the PSB type would be, you should define the segments like this. Okay, basically, one is the PCB type, which is DB. Name of the DB name is, what is that? PNTB HIAS, right? That's the DB name you have given. So you should mention the same here if you are using the particular DB. And proc is nothing but processing option. Okay, so there are different types of processing option is there. Proc is nothing but processing option. Processing option. So there are like G is there. Okay, G, I, or this D. So G is for get the data. I is for inserting the data in IMS DB. R is for replacing the data, and D is for deleting the data. Okay, so this GART is what we say it as A. This GARD, see, if you are giving uh, processing option as, you can give GARD. Okay, or you know, if you no need to mention, we can put it as A. And this processing, why they are putting it as A for GARD, let me tell you, this processing option field, see, whenever you are defining this processing option field in COBOL, the processing option would, they have given only 4 bytes for this basically. Okay, let me show you that. Okay, oh, wait, it's not, let me close it and open it again. I thought it is still not. So 3 point, okay, 3.4, and okay, we have Roads dot. Okay, so if you go this COBOL, how this PSP is defined in the COBOL PCB, basically PSB only. Okay, See, this is the standard thing. Okay, they have given only 4 bytes here. Let me show you the whole PCB. So this is the PCB. They will call it as PCB mask. Okay. So as you can see, this thing is standard for all. Only this key feedback area will change. Okay, I will let you know, guys, what this key feedback area is. Okay. So this is the standard thing, and as you can see here, they have given only processing option. Only 4 bytes are there. Okay, and so if you are giving, if there is a path call is a separate concept in IMS. So if you are issuing a path call, your processing option should be P. Okay, and you are getting the data as well, right? So we can't give GARDP, get, insert, read, because it is more than 4 bytes. So that's why for this they have given this all will have A is nothing but all. A is nothing but GARD processing option. We can get the data as well as we can insert it, we can replace it, we can also delete it basically. Okay. So that's the thing of processing option. I have explained GARD, right? So get, see, if your program is only reading the data, you can just use G. Okay, you no need to mention I and all. If your program is inserting, then you can go with the processing option as I. Okay, GART is explained, and there's one thing called path call. Okay, P for path call. If you are issuing a path call, you should give the processing option as P. Okay, and then processing options. Mostly this is important. So L. L is for load. Okay, I will explain you. And LS is for sequential load. Processing option can be LS as well. Sequential load. Okay. See, whenever you are inserting data and you are doing the first insert, your processing option should be L or LS. Okay. Else, if you are giving I and inserting and your data is empty, I mean database is empty at first, mostly the KSDS file is empty. Okay, because I'm telling KSDS file, any VSAM file. If you are creating a non-indexed VSAM file, if it is empty and you are giving the processing option as I, it will throw error. It won't insert. Okay. So whenever during the initial insert, you should give the processing option as L. Okay. So that's how the PSBs are. And this key length is, see, this key length is nothing but this. We have mentioned some sequential here, right? Sequential. This is the keys. So this keys will be stored in this key length. Okay, I mean that's data. So that's why you should give the key length here. You can give key length as, even though the key length is 21. I mean key length is 21. You can give 27 as well. It won't throw any error. But you can't give 10. It will throw error during compilation. I mean, less you can give, more you can give. It will just include spaces at the last. That's it, right? So here the key length. I mean, if you add these keys, let me scroll slowly. Here sequence is there. So what is the key? 5 byte is 5, right? So 5. Here also sequence is there. 5, 13, and here also sequence is there. 13 plus 8. 21 came, right? So those are the key. So those keys will be stored in this particular key length. Okay, and this is the structure. So by giving here this structure only, the IMS knows I need to go through these segments. See, if here it's the sensitive segment, if you need to go through the patient segment, you should give it here, patient, parent equal to 0, and set segment illness, parent equal to patient. Okay, and the I mean, to which segment you need to go, those segments in the COBOL call I'm saying. Okay, in the COBOL, if your code needs to go through these segments, all the segments should be mentioned in this particular PCB. Okay, so when I coded, I had a doubt like how this PCB mask and PCB is interrelated. Okay, see, for PCBs you won't mention any names here. You understood, right? You won't, you will not mention PCB. This particular PCB name is this. Nothing like that you will mention. If I need two PCB means you just need to give these details again. Okay, see, for this particular you need to give the details again, and your PCB2 will be having only can access only these segments. If you are giving only patient segment, so your I'm in the coding itself. There are two PCB masks, right? So one PCB, I mean, as per this particular PSP gen, one PCB it can go through this segment, and the next PCB can go through only these three segments. Okay, this PCB2 can't go inside household because I didn't mention the relation here in the PCB2. So if I'm using the PCB2 and there is no separate name for PCB2 and PCB1, okay, uh, 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 it's like I'm just giving a PCB and program will know whether I need to program will take like this is the PCB1. I mean, however you are mentioning, see this using is there, right? Uh, okay, this using is there, right? So if you are giving here, if I have given PCB mask 2 first, then it will take the first PCB is the PCB mask 2 and the second one is the PCB mask. Okay, but I mean if you are coding like that, let me clear it and I'm not getting access. Okay, that is fine. So let me go inside again. Okay, so here as you can see in the linkage section, see link in this would be the linkage section. Okay, in linkage section you can view that it no need to be in an ordered way. Okay, even though if I am giving PCB3 here, see PCB2 here and PCB here, I need to define those properly. But in the procedure division you are putting on entry point, right? So basically it will take like, okay, PCB mask, first one is the PCB mask. It will check the in the PSP gen, it will check the first one. So PCB type DB is there. Okay, this is the PCB marks he is referring. And here you have defined the PCB mask, right? In the linkage section, it will go there and it will take that particular structure. Okay, so this is the structure. And then if it is there, and then I'm using PCB mask 2. So it will check, okay, it will go to PSB gen and it will take this particular structure. And it will relate with the PCB2 in the linkage section. So you're getting that, right? In the linkage section, the order can be different, but the PCB gen and whatever order you are giving in the procedure division should be same. If you are not doing that properly, you will get U0476 because it won't able to connect properly. 0476 abund. Okay, in the COBOL code, you will get this abund. So that's how this relation is. During my initial days, was not able to relate this properly. So that's why I'm insisting this point again and again. How the link, how the connection works basically. See, you are giving the PSP gen, the PCB types, and if you are defining, there is no because there is no PCB type name, right? So we can't differentiate what is the name there. So that's why I'm saying how the program will take, like in the using class, it will check, oh, this is the PCB mask. Okay. So this is the structure for the PCB mask. And in the second structure, it will take PCB mask 2. And it will take this particular structure. Okay. So that's how it works. And one more thing, in the PC, as you can see in the PCB mask 2, I mean the second PCB type, if you are trying to get the household segment with using the PCB, second PCB mask, I mean PCB mask 2 as per my coding, it won't allow because you haven't defined the name itself. It won't even go there. It will stop there in the illness itself. Okay. So that's why it is important. If you want to access that particular segment, you should define that in the PCP. Okay. So yeah, pretty much what I need to cover, I have covered. Okay. So mainly guys, connect those. Okay. Okay. So let us go inside the coding now. Let me show you how we can the compilation of PSB and how the storage, what kind of storage we can give. Okay. So let me go inside the, okay, how we can generate the PSB and DBD basically. Okay, so here you are having IMS. Let me create the storage first. Okay, I mean go from the start. So here I have given, this is the storage. Okay, I have defined here, and I'm just giving the KSDS. Okay, main storage is in my KSDS, and the keys are 5 comma 6. So 5 is the key, I mean 5 is the length, and from 6 it will start. Whichever DBD I showed, that's the DBD I'm gonna use. So basically the parent is having 5 byte as unique, right? So I have given the byte as 5. Mm. And I'm creating my overflow data set as well. So that would be this data set, OVFLW. Okay, so let me submit this job, deleting and creating it again. Okay, first what I told first, like first you need to create the storage, right? So storage I have created, and then I need to go with the PSB generation. So let me show you the PSB. So this is my PSB. Source is there, right? Source is there. Okay. So this is the type. Eh, oh, sorry guys. First, then you need to create the structure. The structure is already there. That's what. So first you need to create the storage, and then the structure, basically the DBD gen, right? So go inside the DBD gen. So whatever I have explained, that would be here. So this is my DBD gen, and my access is HISAM. Okay, and I have given a finish and end as well to end it. So once you have written it in source, you need to create the particular library load basically. So for that you should run a JCL. Yeah, run the JCL. So where is the JCL? So so this is my DBD. Okay. DBD Gen JCL. Okay. So let me show you this particular DBD Gen. So here just you need to give your okay source in the sysyn, and in the lmod, I mean you will get the load basically. So I have already created my library, so that's why I have given. If you haven't created that, just create your own library for this load thing and do it. And how this, let me show you the code as well. Go inside this, and okay, so ours is dbd gen, right? Yeah. So as I told, this ASM AF90 is the compiler which will compile and create the load for us, okay, for the dbd gen. I mean if you are making some any mistake, it will throw an error basically. So let me submit it. Okay, okay, it's taking more time. Okay, max is 0. So the load is created basically. Okay, so I mean if you are making any mistake in the source, suppose take like it will clearly show the points which are all the mistake things are there. See, I'm creating a DBD, right? Mm, let us put like here I'm having only 40 there, okay, instead of 45. As I told, the field is huge now, right? I mean, it is more than 40. So it should throw an error. And if you are compiling this, the ASM A90, it won't allow you to create the load. See, it came maxis 8. Okay, so if you are, I mean, start SST. Okay, so if you are check the DBD gen, it will say like the field extends beyond. Some error it will give definitely if you are making any mistake. Field extends beyond defined length. Okay, and the vice versa can work like uh, because segment can have more space, but its field should not take more space than the segment. Am I right? See, I hope you guys understand. So I'm not repeating the points again and again. Uh, See, let us, I mean, in the video itself, we can just make it. So if I'm making the bytes as 45, okay, let me make it as, it's only 45, right? The overall 5 plus 11, I mean, sorry, here it is 5, 15, 30, it's 45. If I'm making it as 50 instead of 45, it is gonna run properly because the extra fields, you can either add some other fields in later point of view for the particular segment. Uh, and if you are not doing that, it will just make it as spaces. That's it. Okay, if I'm compiling it, it is going to run properly. Okay, it thrown max is 0, so that's the thing. Okay, DBD gen is fine now. Okay, let me recreate the compilation again because I mean later videos we should not struggle, that's why, otherwise it will throw error and we should go from the start. We might not know what we did, so I'm correcting it again. Okay, so submitting. So anyway, it will throw axis is 0 only. So again, let me show you the PSBs. Okay, load PSB is there. So processing as per the thing right now. Anyway, we need to do a first load. We have deleted the, I mean, deleted our KSDS, so it will be empty. So okay. So let me put I here. Okay. Uh, During compilation, it will not throw. Okay. In the next video, I will tell you like what needs to be done. So based on the proc opt, you can give it. Okay. If your sensitive segment is missing something, it is definitely gonna give you some error. Okay. And this is the PSB. I'm using only one PCB. Okay, for now. Okay. And in okay, so the same thing, like you should create a load for that for the PSB. So submit. So it will create a load using the processing option whichever you give. We can change the processing option, and once you have compiled and you have the load, it will take it properly. Okay. So now I'm just finishing this video with the generation of PSB and DBD. Okay. And there is one thing called ACB. Mostly we guys are not using that. Okay. ACB is there, which is the combination of PSB plus DBD. I mean, that's the thing. Like it will have this two combination. You guys, we won't use ACB load limit now. Okay, but you want to know. Basically, there are three control blocks. One is ACB and PSP and DBD. Okay, these are the three control blocks. They will ask like what are the control blocks. So ACB, PSP and DBD are the three control blocks. And also like they will ask like what is a child and not like child twin segment, uh, what is twin segment, and one more thing what they will ask, sibling segment. Yeah, so as the name says, see, don't put I mean, theoretically okay, but practically you are not gonna see it as a twin and a sibling segment and all. Okay, it's for the theoretical purpose. They are saying it as a twin segment, sibling segment. Okay, so twin segment. Let me explain. See, twin segment. If something like under this uh, uh, under this illness. Okay, I mean, okay, I'm not able to insert. I mean, I will try insert. So if this treatment is having some other like treatment one, okay, this is the segment name, and it is having the same parent as treatment. So as you can see, illness is the parent for treatment and treatment one basically, right? And if the field and everything is same, basically the segment structure. So if the treatment is having a three field name, and the bytes are all same, and its start positions are all same, and type is same for both the treatment and treatment segment. Basically what is that, it is similar to that, right? So that is what we call it as twin segment. Basically the structures are all same with the same field name and everything. That is what we will call it as twin segment. Sibling segment is nothing but what, if consider the same treatment segment, if it is having the field name structure, I mean the structure is different. Say like the first field has the length as 5 for treatment, and treatment 1 is having the length as 4, then it is not similar, it is not twin, it is a sibling basically. So that's the sibling and what sibling and twin segment means. So I mean in the theoretical wise how the hierarchy works, that's what it's important. Okay, this is what this twin and sibling and all, it is theoretical wise. So just imagine guys like how the hierarchy works now. So first it will go into patient. Whenever you are issuing some call, it will go to patient now, and then it will go to illness, and then it will go inside the treatment, and then it will go into treatment one. Okay, because it is the child of treatment, and top to bottom, left to right it will go. So once the treatment one is completed, then it will go into billing, and then the payment, and then the household. Okay, so as I told, only this how the flow works, that is what the important. This treatment, okay, whether it is twin, this thing and all, it's not important. How the data is retrieved and inserted, that's what is important in IMS DB. Okay, guys, I'm just concluding here. Okay, remaining things I will put it on the next video that will cover like how we can. I mean, what are the DLI codes are there, commands basically. What is the DLI, BMP, MPP, and then how we can code. Okay, and a few calls are there. Let me explain it in the next video. Thanks a lot, guys. Yeah, bye. Have a nice day.